Hello everybody. So today we will talk about the chapter related to mortality on our course Population and Society. And this chapter is divided in all these different subtopics here: introduction, and then measurement of mortality. And in measurement of mortality, I'm going to talk specifically about these two techniques to estimate some more standardized mortality indicators. One is standardization and the other one is life table. With the life table is the one that we estimate life expectancy at birth and also at all different ages. And then we're going to give you a short history of mortality in the world and highlight some mortality trends and causes of death. Then focus a little bit in the US, talking about mortality and longevity in the United States, and then talk about infant mortality and some future course of mortality, some future studies that some researchers have been talking that will be interesting for mortality. And I will give you some websites in which you can get some data about the ongoing the coronavirus pandemic, and also some articles talking about this pandemic in using different perspectives. So I'm going to talk about this at the end. Right now, I will just talk about the slides related to the introduction and measurement of mortality, and then the following one about standardization, then the other one about life table. So we'll talk on separated videos about each one of the subtopics, so we have shorter videos for you to watch. And so here in this chapter about mortality, one important thing to highlight is the impact of mortality varies significantly according to social and demographic characteristics. So whenever we are talking about mortality level, mortality trends, and mortality changes over time, it's good to know the variation of mortality by age group, by sex, by race, ethnicity, by social class, by marital status, and also by area of residence. And the levels of development and medical conditions and a host of other factors, they influence life expectancy. And life expectancy is one of the indicators to tell us about the mortality levels in a specific country or in a specific state, for example. So all these different factors, they influence mortality, and also economic development, medical conditions, and series of other factors influence life expectancy, and we're going to talk about them throughout this lecture. So one important thing that we have been talking since the beginning of this course is that we have been seeing throughout history some changes in the causes of death. There have been major changes of the historical record in the main causes of death. So people used to die mainly of infectious and parasitic diseases in the past. Some centuries ago, these were the main causes of death of the population. And today, the major causes of death in developed countries are heart disease, cancer, and stroke. So the major cause of death are different in high and low levels of life expectancy. So in the past, people used to die mainly of infectious and parasitic diseases. In more recent years or in more recent decades, mostly in developed countries, you have a change. But it's still nowadays countries with different levels of economic development, and so different levels of life expectancy, they also have different causes of death. More developed countries, they have high levels of life expectancy, and so you see more deaths related to these causes: heart disease, cancer, and stroke. More developing countries, they have lower levels of life expectancy, so they have more deaths caused by infectious and parasitic diseases. But for example, the coronavirus pandemic that we're experiencing right now, it is an infectious disease, and it's affecting not only developing countries but developed countries as well, as is the case in the US and a series of Western European countries. So I'm not saying that infectious diseases they disappear from developed countries, but that the proportion of people that die for these other causes increases as these countries experience economic development and higher levels of life expectancy. And I'm going to provide some examples about that throughout this lecture as well. So in terms of measurement of mortality, the way that we quantify, that we estimate indicators to talk about the level and trends in mortality is central in demography. And this is not something that started in some years ago or some decades ago. It has been done for several centuries already. So the measurement of mortality dates back to John Grant, who is considered to be the father of demography. So back in the 1600s, he did some studies using vital statistics data from London, and then he published his bills of mortality, and was like one of the first studies that actually estimated mortality indicators using some sort of life tables at that time. So it was the first time that a demographer or a scientist, in this case a statistician, John Grant, estimated the number of deaths by age groups, and this is the basis to estimate life expectancy as we saw developed in upcoming decades after the bills of mortality were published. So mortality refers to the relative frequency of death in a population. And basically, we have two concepts of mortality: lifespan and life expectancy. Lifespan is pretty much the numerical age limit of human life. What's the maximum recorded age at death that someone, a human being, had ever lived? So this French woman, she is considered to be the one that lived most years throughout her life, 122 years and 164 days. There is some controversy about that, some recent articles questioning whether she lived that amount of time, but it gives us an idea of the biological limit of human life. But more important for demographers is life expectancy, which is an indicator about mortality. That's pretty much the average expected number of years of life to be lived by a particular population at a given time. So we get the mortality rates for a specific population, a specific time, and we get those mortality rates by age groups, and then we are able to estimate this average expected number of years that people would live if they were exposed to those mortality rates by age groups throughout their lives. And we're going to talk more about that in detail when I explain how to calculate life expectancy with the life tables. The simplest indicator for mortality that we have is the crude death rate. The crude death rate, symbolized by CDR, is pretty much the number of deaths that happen in a specific year in a specific population divided by the population at the mid of the year in that same country, in that same society. And we multiply by 1,000 because this rate here, it's really small. That's why we multiply by 1,000 so we don't have such a small number. So just to give you an idea, in the United States, back in 2013, 2,596,993 people died in that specific year. And in the mid of the year, back in 2013, we have a population of around 316 million people in the US. So divide one by the other, number of deaths by the size of the population, and then we multiply by 1,000, we have a CDR of 8.2. And just to give an idea of this, how this number compares to other countries, the world range of the crude death rate in 2014 was from 1 to 21. So the United Arab Emirates and Qatar had really low crude death rates, and Lesotho, an African country, had a really high CDR of 21 deaths per 1,000 people in that specific country. And so when we are comparing crude death rates among different countries, we have to be careful because different countries have different age compositions. When crude death rates are compared among countries, differences are sometimes due to differences in age composition. So just to give an idea of the previous examples from the previous slide. So the previous examples meant that there were 8 times more deaths per 1,000 people in the US than in the United Arab Emirates. Because if you just go back to the previous slide, the US had 8.2 deaths per 1,000 people in the US, and the United Arab Emirates had just 1 death per 1,000 people living in the UAE back in 2014. So this rate here, 8.2, is 8 times higher than 1. So that's what we are talking about it here right now. So why is the crude death rate of the US 8 times higher than the crude death rate in the UAE? The main reason is that the United Arab Emirates is much younger in average age than is the US. So we have a much higher proportion of younger people in the United Arab Emirates than in the US. The US population is much older compared to the UAE. And younger people have lower death rates. So overall, younger people have lower death rates, they have lower chances of dying. So the CDR in the UAE is smaller than the CDR in the US. So just to clarify this, countries with large proportions of young people, so they will consequently have small proportions of older people, and usually they have lower crude death rates, because with larger proportions of younger people, young people, they have lower chances of dying, and then that makes the overall crude death rate having a small level. On the other side, countries with small proportions of young people and large proportions of old people, they usually have higher crude death rates because you have exactly large proportions of older people, and these old people have higher risks of dying. And usually developing countries, they have larger proportions of young people, and usually developed countries such as, for example, the US, Canada, Australia, and Western Europe, they have smaller proportions of young people and large proportions of old people. So the CDR is not a good measure when you're comparing countries that have different age compositions. And that's what we're going to talk about, standardization in the life tables, in order to estimate some mortality indicators that take into account the age composition of these countries. So if age structure has changed over time, the crude death rate should not be used to compare the death experiences, even if you're talking about the same population, but in different points in time. So let's just see the case of the US. If we just look at the crude death rate, it did not change much in 54 years between 1960 and 2014. So it dropped from 9.5 deaths per 1,000 people to 8.2. It dropped, but not so much, and we would expect that it would drop more. But that's because the CDR is not capable of capturing the reduction in mortality when the population becomes older. The US improved the mortality, so it means that less people are dying. We have lower mortality rates overall. But this specific indicator, the crude death rate, is biased by the fact that now the US population is older in 2014 compared to 1960, and older people have higher chances of dying. That's why this number did not drop as much. So the US became older between 1960 and 2014. Just to give you an idea, the median age back in 1960 was 29 years, and in 2014 was 37 years. So exactly because the US population is getting older, and older people have higher chance of dying, the crude death rate did not decline so much in the US. And why is the CDR, the crude death rate, called a crude rate? Because the denominator has the entire population. So we are not only talking about a specific subgroup of the population, the denominator. The denominator has the entire population. So that's why it's called a crude rate. But we know that different subgroups of the population, different population members, are not equally at the risk of dying, of experiencing death, as other subgroups of the population. So it would be good to have in the denominator specific subgroups of the population, and then in the numerator of this formula, we would have deaths for that specific subgroup. And we could estimate these specific mortality rates by a series of different characteristics of that population. So we could do it by age, by sex, by race, ethnicity, by socioeconomic status, and by a series of other characteristics, exactly because we know that death rates and the chances of dying, they vary by all these different characteristics of the population. So one way to start is to calculate death rates by age, exactly because they vary considerably by age. Older people have higher chance of dying than younger people. So another measure that we can use to analyze death rates in specific countries are the age-specific death rates. So demographers use these age-specific death rates as a more precise way to measure mortality. Instead of dividing the overall number of people who are dying in a specific year to the whole population that year, we get the people dying in a specific age group divided by the population of that specific age group. And the subscripts here, the X and N, we are saying that these are deaths to persons age X to X plus N. And here's the number of people, the persons in the population who are age X to X plus N. That's the standard notation in demography. So if we had here D510, that would mean that we are talking about deaths of people from 5 to 15 years of age, because it's from 5 to 5 plus 10, so it would be 15. Usually, we have these mortality rates done by 5-year age groups. So that's an example here. This mortality rate 15.5 means that that's the mortality rate of people that goes from 15 to 15 plus 5. So we're talking about the age group 15 to 19. 15 plus 5, because we include here people who are also 15 years of age. So it's 15, 16, 17, 18, and 19. So it goes from 15 to 19 years of age. So the X is the initial year of the age group, and the N is the width of the age group. But the N includes the first age. So, and in the previous example, when I said if I had here 5 and 10, so it would be actually 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it would go from 5 until 14. And here, but the usual notation that we have for mortality rates by age groups, we usually have the width equals to 5. So it would be only these 5 specific ages, 15, 16, 17, 18, and 19. Okay, and this notation, we usually can use the capital M for the age-specific death rates or age-specific mortality rates. They can also be called age-specific mortality rates, and they can be symbolized by the capital M, XN, or the ASDR, which stands for age-specific death rate. And just an example of these age-specific death rates we have in this graph here for the US in 2007. So here we have the age-specific death rates from people who are below 1 year of age, and then 1 to 4, 5 to 9, 10 to 14, until 85 plus. And in the first group here, it's broken only for those who are below age 1, exactly to capture infant mortality rate, those who die before they reach age 1. And then you have 1 to 4, but then after that you have the 5-year age group. So here it starts being like 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. And the final age group, it's a more open-ended interval, so it's everybody who are at least 85 years of age. When we look at these trends here, it doesn't look like that there is variation by these age groups, but if we just do a zoom in of this portion of the graph, we see a lot of variation, not only from those who are below 1 year of age, but also for those that go from 1 to 39 years of age. So as we saw in the fertility chapter, we had the age-specific fertility rates, and they were estimated for a woman between 15 and 49 years of age. So we had a series of different fertility rates by age groups, not so many age groups as we have here, because it was only from 15 to 49 years of age. But we have all these different points here and for fertility. And the same thing we have for mortality. For fertility, we combined those age-specific fertility rates into the total fertility rate, the TFR. We pretty much just added up all the age-specific fertility rates and multiply by 5 because we have the width of the age group equals to 5. For mortality, it would not make sense to add all these rates here and then multiply them by 5. Let's say, even if we start only with this group here that have a width equals to 5. If we get this group here that has a width equals to 5, up to this one here, if we add them all and multiply by 5, that number, that let's say if we in fertility we call it the total fertility rate, in mortality would be called the total mortality rate. The total mortality rate, it's not reported, it's not something that we calculate because it does not make sense in demographic terms. Why it does not make sense? Because that number would tell us if someone was exposed to these age-specific mortality rates from 5 to 84 years of age, they would die 1, 1.5, 2, 3 times throughout their life. So that doesn't make any sense because we die only once. For fertility, it makes sense because if we get those women between 15 and 49 years of age, we calculate the age-specific fertility rates, add them all, and multiply by 5, we would say if this woman were exposed to these age-specific fertility rates throughout their childbearing years, they would have 1, 1.5, 2, 2.3, 3 children on average, for example. So that makes sense because women can have more than one child. But for mortality, it does not make sense because we cannot die more than once. So that's why we have to come up, demographers had to come up with other measures of mortality that do take into account the age composition. They're not so simple as the crude death rate, so they have to take into account the age composition because some countries have more older people and older people have much higher risk of dying compared to younger people. So we had to come up with a measure, and the different measures that I'm going to talk in the next video is gonna be standardization, and then after that we're gonna have the life table. That's the table that we use to estimate life expectancy at birth, and also for each one of the other age groups, as we're going to discuss in the coming videos. So that's it. Thank you very much.